This is a demonstration of the Laurell WS600 8NPP MEG spin coater developer. This particular spinner has been configured to be a dedicated developer spinner. This compact tabletop spinner will accommodate wafers up to 200 millimeters round and 7 inches by 7 inches square. It has a maximum rotational speed of 3,000 RPM and is equipped with a 1 3/4 inch chuck, along with an 11.5 inch ID bowl. It is powered by 120 volts AC and requires a minimum of 60 psi of N2 or CDA. It also requires 15 to 25 inches of vacuum. We're going to go around to the back first. Now there's a lot of things connected to this spinner, so I'm going to take you through them. I've labeled a bunch of things. First off, this particular one is equipped with 4 valves that you can use here, and the entire piece of equipment has 8 different pilot valves. 4 of these are being used for the upper valves, and I've labeled the other ones here. This one here is exhaust purge, and that goes to the exhaust line. This here is the dome purge that goes up to the dome, and these 2 are unused. So if you have to power 2 other air valves or something else connected to this, you can easily program them in the system. This is a split exhaust and drain. So you have an exhaust up top and you have a drain that goes out through the bottom. This is where you connect your vacuum, and this is where you would connect your nitrogen or your CDA. And there's also a second output here that you can use for an extra supply as well. The entire system turns on with this little button right here. Turn this on and go back around to the front. Start off by showing you the manual. The manual is very good. It's easy to read. So I'm just going to step through a couple things here that might be easy to see. There is the installation section, which gives you everything you need to know about hooking up the piece of equipment, safely I might add. The next section is the operational section. Now, basically, the instructions here do mimic what you'll see on the display over here. You might see the first line a little bit different, but other than that, it's pretty much the same. So you shouldn't have too many problems programming this piece of equipment. If down the road you decide that you want to interface this to a house computer or a laptop, there's an entire section in here on how to hook that up to a computer, a separate maintenance section, which is important because with a developer, or if this was used as a photoresist coater, it can get very dirty, and there's a lot of good hints on here on how to clean things out, how to connect up your charge bottles. Also, with regards to the valves in the back, I had shown you the 8 pilot valves. You can go into the programs here and you can individually turn them on and off as well. And there's some instructions also for hooking up both the drain and the exhaust as well. Now normally the system comes with, or the other systems come with a worksheet for programming, and most of them are alphabetical. However, this particular unit, if you'll notice in the back, is numbered. The valves are numbered. So I took the liberty of making some of my own sheets here that I'll supply you with, so you can make sure that you know which valves are turned on. You can identify your valves as DI water, IPA, or whatever developer or chemicals you're using here. Before we run it, let me just show you a couple things. We're going to open the top. Now you notice when I open the top, this comes on and says lid open. That's a safety precaution, so you can't possibly run the machine with the lid open. This particular unit is somewhat of a custom-made unit. It has the normal ports on the top, but it also has 3 additional ports here that have been fitted to the dome as well. What we're going to do to start off with first is we're going to do just the speeds. What I like to do is hook up an external infrared tachometer. This thing is pretty cool. It is trying to see quite a distance through the outside of this, so it might be a little off. Let me see if I can get that on there. And I'm going to start off. Okay, I have written, or I've taken 2 original programs that were in there, and I've altered them. The first one is a speed test only. I do not operate any of the valves. So we're going to run from 100, 200, 500, 1,000, 2,000, 3,000, which is the maximum, and back down again. I've noticed that a lot of the programming for not photoresist spinning, but in particular developing, will have the wafer stop and have a slight delay. So it's a little tricky. You have to read the manual, but you can also, even through the different steps, you can insert delays as well. I'm going to run this one first, and let me see if I've got my meter on there correctly. To turn the vacuum on, once you put your wafer or your workpiece on the chuck, just push. There you go. Now, as long as you have between 15 and 25 inches of mercury in vacuum, you should be okay. Okay. First, we're going to go to 100. Followed by 200. Followed by 500. 1,000. 2,000. 3,000, which is our maximum speed. Back down to 2,000. 1,000. 500. 'And a short delay, bouncing down to 200. 100, and then really slow, we're going to bounce all the way down to 50. And let's see if we get up there. 50. Not bad. And that completes. Now, in the next one, I'm going to move this out of the way for now. I've written this one here to be able to not only test at different speeds, but also to exercise the different valves that are available to use. Now again, once you have decided which valves and which main drive valves you want to use for your developer or your IPA or DI water, you can pretty much identify them here on this chart as well. So we're going to start. That's another thing too. Whenever you're done with a run, you should open the top because this will signal the unit that that particular run has been completed. This way, if you push the run button again, you won't accidentally redevelop the wafer that you just finished. So we're going to close this up, and I'm going to change to my other test one, which is number 2. Okay. Now, in this one, in the first step, I'm going to run all the way up to 3,000. Now again, normally in a developing process, you wouldn't be running at such fast speeds, but I wanted to be able to give a good demonstration of how this can go fast, slow, or however you want to set it up. So in the first one, we're not going to have any valves on at all. In the second step, we're going to drop 1,000 RPM, and we're going to turn on these 3 valves. Now, just let me mention valve 8. Valve 8 is the purge that actually goes to the drain as well. We're going to run, then we're going to drop that down to 1,000, leaving the same valves on. Then we're going to drop all the way down to 200 and switch these valves. Then in step 5, we're going to jump back up to 3,000 and power these valves on. There's going to be a slight delay while it decelerates down to a much lower speed, followed by our final step at a 100 with, once again, no valves on. Now, the best way to see this would be around the back. This way, you can actually watch these valves being turned on and off. You can't quite see these. These are not being actuated. These are your spares. But both 7 and 8 will be actuated as well. So, if you look in the top here, through these transparent covers, you'll see that when these valves are running, they open and they close. So, here we go. We're going to start with our first step, which is at 3,000, and all of our valves are closed. Then we will go to 3 and 4, and I know this one is now open as well. That's number 8. We are now going to drop from 2,000 RPM down to 1,000 and leave these valves continue to be open. Then we're going to drop way down to 200 RPM. And at that point, we're going to switch our valves to 1 and 4. We're then going to run it all the way up to 3,000 again and switch to 2 and 4 along with 7, which is now running this purge up into the dome, followed by a slight delay between the slow speed, and now we're at 100 with all the valves once again closed. If you read the book and you practice a couple of times, you can get to the point where you can use this fairly well. If we go back, let's say, to the main menu, we're going to shift over here to the main menu. Now, the main menu allows you to do a bunch of things. For one, you can set up your programs here. I'll just go into a couple here. This will allow you to set up your programs. Okay, we'll go back to our main menu. This will show you the status of your valves and your sensors. There are sensors that allow you to monitor the exhaust and the drain. So we'll go into there. And this allows you to step through the different sensors as well, letting know that the last one was number 9, etc. We'll go back one more time. This is statistics. This is sort of pretty cool. This will keep track of what you do as far as the the time that the machine has run. We'll go back one more time. We have error log. That's pretty good too. If you should have a problem and something doesn't seem right, this is a log that you can go in. It'll tell you the faults. It'll tell you when it happened. Here's one that I made. I made a mistake last week on this. Still got the record of it. And there's system setup that allows you to set up the making sure that you have a lock for the CDA. For example, if you're below 60 psi, it will not run. If you're below, as you can see, I believe I said 15 inches of mercury on the vacuum, it will not run. So that's very helpful as well. And then finally, we have tune, which is an option. And we can go back to our run mode here. Now, if you want to edit and change something, you'll notice that when you're in your run mode here, that this this display here will blink saying edit. That simply means that if you hit enter, you can then edit. You can cursor your way back. For example, if I wanted to change, let's say, the speed down to 1,000, I could go 1, 2, and then after each change, make sure you push enter. Now, if I went back to run that again, okay, we should see that now, yes, instead of running at 3,000, we're now running at 1,000 on our test program. At any time, you can hit stop, and you can open the top here. And from a safety standpoint, if, let's say, we run it again, and I were to try to open this, I can't open it. If you look from the side here, you'll see a little red button. And what that button does is it prevents you from opening the top when it's running. So you would definitely have to hit stop. It'll then de-energize that, and you will be able to open it. So this is a pretty simple system to use. It has lots of accessories on it, and lots of capability. And this completes this demonstration.